So the purpose of this video is to have a look at a topic in GCSE chemistry which students find fairly difficult, although it's really quite straightforward. Hopefully when you watch this video you'll think so anyway. And it is how to write half equations for GCSE chemistry. Now don't confuse this with AS chemistry where you may have to write half equations for redox equations and combine those. The two things are slightly different. So let's get started. Okay, I'll keep this video pretty short. So half equations tell essentially half the story. So if, for example, I give you a full equation here, if I took, let's say, potassium was to react with chlorine, you would then have to work out, perhaps for maybe 1 mark, the product of that was of course potassium chloride. Okay. The next thing that you would be asked to do then maybe was to convert that into a balanced symbol equation. So you'd write potassium, you would write chlorine knowing that it's diatomic as KRCl2, you would write then potassium chloride. Potassium is a group 1, has a valency of +1. Chlorine is -1, so they react in a 1-to-1 ratio. And then you'd remember finally to balance up all your atoms, you've got 2 chlorines on the left, so I need 2 chlorines on the right. The only way I can get them is to put a big 2. Remember, you cannot do that. Okay, putting a small 2 at the bottom right hand of the chlorine makes your answer incorrect because it changes the formula of the potassium chloride. Okay. And then here, then that 2 also means that I've got 2 potassiums here. Okay, therefore I need 2 potassiums here, and that's not all balanced. The third part of the question might then be, okay, we'll convert these into the half equations that I just spoke about. So when you're writing half equations, you have basically got 4 steps to follow. The first step is you write down, okay, your reactant and your product. So you'll have 2 half equations here. You'll have potassium. Now what does the potassium go to? If you think about it here, this is now a potassium ion, and that's really important that you get your charges correct. Anything that is pure and on its own, so potassium and chlorine are the elements on the left hand side, they have no charge on it. So there's a 0 charge on that. Now we don't write the 0 in, but there's no charge in that. Once it's reacted, then we have a charge to deal with. If we look on the left hand side for the chlorine, that starts off with chlorine gas, which is diatomic of course, and that goes to chloride ions. And you should know by now that chloride ions are in group 7, they're -1 ions. Okay, right, so that's step number 1. The second step is that you balance any atoms that are in this equation. Now for the potassium, we've got nothing to do. There is 1 potassium on the left and there's 1 potassium on the right. For the chlorine, we do have something to do. Okay, we have got 2 chlorines there, so I do a 2 there. Now, some people might do this, all right? Now that is incorrect. It is only when chlorine is pure element on its own, diatomic chlorine, that it exists as Cl2. And if you think about it, guys, by putting a 2 down here, what you're saying is I have 1 Cl minus, which is attached to another Cl minus. Well, if you actually give it some consideration, you would know that those 2 negative charges would actually repel each other. So for 2 Cl minuses to be together actually wouldn't make any sense. So diatomic molecules only exist as diatomic molecules when they are pure elements. Now some people might go, oh well, what about Mg, which is a 2 plus, and Cl, which is a 1 minus? MgCl2, is chlorine not diatomic there? No, it's not. What you have there is a magnesium, which is 2 plus, and you have 2 chloride ions again. So this 2 here is telling me I have 2 chloride ions, not pure chlorine in its elemental diatomic state. Right, so try and get those sort of things right in your head. Right, so there's our second step. We have balanced our atoms in that equation. The next step that we do is we write the total charges underneath each species. So the total charges, okay, so we'll just write that down there. We write the total charges under each species. Now you may or may not have to do this step, and as you get a wee bit quicker and a bit better at these, you can probably start cutting out this step here. Alright, you can't cut out step 1 or step 2, those are going to be part of your answer. Right, so the total charge under the potassium here is 0. The total charge under the potassium ion is positive 1. The total charge under the chlorine here is 0. And the total charge under the chloride is, we have each chloride is -1. I have 2 of them, it's -2. Okay? Right. The final thing and the final step that we've got to do, step number 4, is you got to balance those charges. So in the same way as you balance the atoms earlier, you must also have charges balanced. And the only way that you can balance charges is by using electrons. Now, electrons are -1 charge, so you can only balance using negative charges. This is where your maths gets tested a little bit. So we have got 0 on the, I'm going to deal with the potassium one first. We've got 0 on the left hand side and we have +1 on the right hand side. How am I going to make sure that both of those charges balance? Well, if I put an electron on the left hand side, that now makes my total charge on the left hand side -1, and my total charge on the right is still +1. So clearly that's not correct. My charges are no longer, are not, still not balanced. Okay, if I go and put an electron here, so +1 plus -1, you do that in your calculator if you want, that equals 0. So there you go, that's that balanced. Okay, so you have an electron on the right hand side. If we go down below here, okay, we have 0 on the left and we have 2 minus on the right. So let's put 2 electrons here because we're going to need 2 negative charges, aren't we? So we have 2 negative charges. Now how does that make my charge on the left hand side in total now? Well, I have 2 minus from the 2 chlorides. I have 2 minus from the 2 electrons. So -2 plus -2. I now have a total of -4 on this side and I have 0 on the right hand side. So clearly those charges are still not balanced. So I've made a mistake there. That's the mistake that many students make. So we have to put the 2 electrons on the left hand side. So I have 0 from the chlorines and I have -2 from the electrons. So the left hand side of the arrow is -2 charge, right hand side of the arrow is -2 charge. I have indeed now got my electrons on the correct side, and equally importantly, I've got the correct number of electrons. Okay, just very quickly, I know it's not really part of half equations, but it would crop up. This shows that the potassium from the left hand side is no longer attached to the electrons, so the electrons have been lost in this instance, and that is a reaction called oxidation, which you will also have to know, perhaps not in this topic, but certainly in another one. And if we look down here, the chlorine is actually picking up the electrons, so it's gaining the electrons. So electrons in this instance have been gained, and that is a reaction known as reduction. Okay, so all of this reaction up here, okay, because both oxidation and reduction are occurring up here, we would refer to that reaction as a redox reaction, both oxidation and reduction occurring. Right, we'll look at another couple of these guys, and then maybe if I put them up on the board, perhaps what you might do is pause the video and then hit play whenever you've got yours completed and check that your answer is correct. Okay, so let's say the examiner said to you, had to write a half equation for magnesium ions going to magnesium metal. So first thing we do is write out our species. Well, magnesium ions is in group 2, okay, goes to that. Magnesium metal, that's just the pure element, there's no charge on it, it's pure magnesium. We balance them. Well, there's 1 magnesium on the left and 1 on the right, no balancing required here. Then we put our charges in, so we have +2 on that side and we have 0 on this side. Any element is 0 charged, so I'm going to need to balance up those charges. I can only use electrons and negative charges, so I'm going to need 2 electrons on that side. Okay, right, let's have a look at another one. Let's look at a sulfide ion, and a sulfide ion is going to pure sulfur. Okay, you can spell your sulfur with a PH, it's not a big deal. Right, sulfide ions are in group 6, the same group as oxygen, so sulfide ions are 2 negative. Sulfur is just S, pure element on its own. We don't have to balance anything up here. Okay, we've got just one sulfur left, one sulfur right. -2 is the total charge on the left, 0 is the total charge on the right. I need both of those to be equal using electrons. Electrons are negative, so if I put electrons over on this side, that's going to make it even more negative, which would be wrong. Hopefully you can see that. So I'm going to need electrons on this side, which is going to start making this negative sign, or sorry, 0. It's going to start making that 0 negative. How many do I need? Well, I'm going to need 2, because that gives me a total now of +2. So everything in that equation is now balanced. Okay, let's have a look at oxide ions turning into oxygen gas. Right, so oxide ions again are group 6, they're -2. Oxygen gas, remember, is diatomic and it's pure state, you have to know that. This time we need to balance up our atoms. Okay, so I have 2 oxygens on the right hand side, so I'm going to need 2 there. Remember, never do that. That's completely incorrect whenever it comes to ions, guys. Okay, so I have 2 ions on the left. Now I do my charges. Well, I have 2 of those, each of which are -2. Okay, so my total charge on the left is -4. My total charge on the right is, of course, 0. So I can only use negative charges, so I'm going to have to apply them to the right hand side because I've got to make this negative. So I'm going to need electrons on that side, and I'm going to need 4 of them because that now gives me a total of -4 on the right and -4 on the left. Okay, let's have a look at hydrogen ions being converted to hydrogen molecules. So hydrogen ions, you should know, are H pluses from maybe your acid and base theory. Okay, it goes to hydrogen molecules. Hydrogen molecules are one of your diatomics that you have to know. So again, we've got to balance these up. Okay, 2 to there. Total charge on this side is +2. Total charge on this side is, of course, 0. I've got to use my negative electrons. So if I use electrons on this side, let's say 2e minus, that brings that side to -2. So that's, of course, incorrect. Just be careful of that. Sometimes people do that. So I do need electrons, but I need them on this side, and that gives me +2 plus -2, which is, of course, 0. So my 2 sides of the equation have now balanced out. Okay? Right. So I think I've done probably enough there. If you use your textbook, your CA textbook, and you go to page 295, guys, 295 that is. Alright, in your CA textbook you'll find lots and lots of examples of these which you can use. Okay, hope that short video clears up any problems that you were having with that.